Hopefully at this point you have visited several of the links and have come to figure out how to identify what digits are significant and what digits are not significant. But I just want a chance to summarize everything and give everyone a last opportunity to be sure that they have everything straight. So when it comes to the numbers in a measurement, the numbers 1 through 9 are always significant figures. So this means that the digits 1, 2, 3, 4, 5, 6, 7, 8, and 9 always count as significant. What this reveals is that the only digit that is sometimes significant and sometimes not significant would be 0. Now there are several different kinds of zeros. The first kind of 0 is what's known as a leading 0. And this is the kind of 0 that leads off a number. So this typically happens with small numbers like 0.00123 centimeters. Remember, significant figures are only parts of measurements. Pure numbers have an unlimited number of sig figs. So leading zeros, it turns out, do not count as significant. And that seems very odd to students because, of course, a ruler that was able to make this measurement is obviously a very sensitive ruler. And yet, all those extra digits that we get from this ruler, some of those digits don't count as significant. This is really one of the more challenging things to understand about significant figures, and something that I can explain to anyone that's curious after we talk about the metric system. So in this case, this number contains 3 sig figs, the 1, the 2, and the 3, because the numbers 1 through 9 always count as significant. The zeros at the start of a number do not count as significant. It also doesn't matter where the zeros are in relation to the decimal point. The 0 at the very front of the number before the decimal point is just as insignificant as the 2 zeros after the decimal point. So this number only contains 3 sig figs. Another kind of 0 is what I call trapped zeros. They're also known as captive zeros, and you would have seen that if you followed some of the links. So a trapped 0 is a 0 that is physically located between non-zero digits. So for example, the number 102 grams or 1002 grams. Both of these numbers contain trapped zeros. So of course the 1 and the 2 in both cases count as significant. And since we know each of these measurements to the ones place, that means we must also accurately know each of the measurements to the tens place, and of course in this case the 100s place. So trapped zeros or captive zeros are thus revealed as being significant figures. Now this leaves one kind of 0. And that would be trailing zeros. And trailing zeros are zeros that the number trails off with or ends with. So for example, 123,000 liters, for example. Now trailing zeros are the ones that are conditional. There are cases where they do count as significant and cases where they don't count as significant. So imagine if someone asked you to look at a pool of water and estimate how many liters of water were there. You might say, looks like about 123,000 liters. It would not be unreasonable that someone whose business is water would be able to estimate to the nearest 1,000 liters. But if someone else said that there was 123,000.0 liters, well, this does not look like an estimate. This looks like the result of careful measurement with some sort of measuring device, because it's not typical that a human could estimate liquid volume to the 0.1 liter mark out of 123,000 liters. So while these two numbers are numerically the same amount, in this case liters, but we could substitute out, say, for dollars, you'd have the same amount of money in both cases. But the way that the amounts are described is very different. one with much fewer sig figs and the other with a great deal more sig figs. So it turns out that trailing zeros are significant if a decimal point is present, and they are not significant if a decimal point is absent. So in the first case, 123,000 liters, that only contains 3 sig figs. But in the second case, 123,000.0 liters, that contains 7 sig figs. So the 3 is the last non-zero digit, and all the zeros that follow, both before and after the decimal point, are trailing zeros with a decimal point present, which means those zeros all count as significant. So every single digit in that number is actually a significant figure. Now those are the really common rules. These are the ones that will come up time and time again as you go through the problems. But there are some other rules that sometimes come up, and probably the biggest, and this certainly happens in the lab, would be the idea of defined values. Now, defined values are not measurements. Again, remember, pure numbers have an unlimited number of sig figs. So when I say that I have $5, I have exactly $5. That's the same as saying 5.00000 all the way to infinity dollars. But when you're talking about a defined value, like say twice the radius is equal to the diameter, there are numbers in this problem, right? There are the 2 here and the understood 1 in front of the diameter, but there's no measurement here. I don't know what the size of the radius is, nor do I know the size of the diameter. The numbers 2 and 1 are part of definitions for the radius and the diameter. Here's one that's more common for you folks, and that would be to say that 12 inches is equal to 1 foot. Well, that's exactly true. This is how you define what a foot is, or if you flip it around, what an inch is, 1/12 of a foot.